Hello, this is Captain Chaudhari. In my series of videos on basic stability calculations, today we are going to do a calculation which is kind of going to revise all your basics. We are going to talk about the dimensions of a cylinder. We are going to talk about the moment of inertia. We are going to talk about free surface effect. We are going to talk about the TPC, a lot of things. So let us enjoy this numerical. This is a cylinder. Say the radius is 4 meters. The height is not given, but the cylinder is floating in salt water 1.025, and it's floating at a draft of 1.6 meters. And then what happens is an empty cylinder has got the kg of 1 meter. Right? Now it is assumed that the thickness of the cylinder is negligible. For all practical purposes, the thickness is not there. Now this is filled up with a liquid of density 0.8. Say maybe it's an oil of density 0.8, and let us say 50 tons have been poured into it. So it will acquire some level. We don't want to go into the details at this moment, but 50 tons of oil is poured in this cylinder. The displacement would change, the free surface effect would be there, the GM, kg, everything is going to change. We are going to do all those calculations. So when the cylinder floats with the draft of 1.6 meters while it is empty, we can find out what is the displacement. Displacement is the liquid that is displaced by submerged portion, that is 1.6 meters, multiplied by the density of liquid in which the container is floating. So the volume is of the submerged portion, the volume is pi into r square into the draft. This is the volume multiplied by the density 1.025 is the displacement light. So this is 3.14 into 4 square into 1.6 into 1.025 gives me 82.394 metric tons. So this is the light displacement. Now when 50 tons of oil is poured into it, we must know what is the volume of oil. The volume of oil that is poured will be we know mass is equal to volume into density, right? So volume would be mass divided by density. So that is 50 divided by 0.8. 50 divided by 0.8 gives me 62.5 meter cube. So what is the height that is attained by the liquid will be given by the volume divided by area. So volume divided by area, that is 62.5 divided by area of the cylinder. The horizontal area is pi r square, that is 3.14 into 4 square. So that is 62.5 divided by, gives me the height as 1.244 meters. That will be the height of liquid. So liquid is just up to this height. So this is going to increase the draft of the vessel. So total displacement is going to be initial displacement, that is 82.394 plus the weight of oil, that is 50. So total displacement is 0.394, 132.394 tons. If I want to find out what is the draft, it's a very simple procedure. The total displacement, that is the empty container plus oil, should be equal to pi r square. Pi r square is the circular area of the cylinder, multiplied by draft, we don't know the draft, multiplied by 1.025. So the principle used is the volume that is displaced by submerged portion is actually the mass of the entire cylinder. So if I want to find out the draft is going to be 132.394 divided by 3.14 into r square, that is 16, into 1.025. So 132.394 equals divided by 3.14 divided by 16 divided by 1.025. That gives me the draft as 2.571. The draft is 2.571 meters. Why did I find the draft? I found the draft. I'll write down certain details here. So MT is 82.394. Oil is 50 tons. The new draft is 2.571 meters. Now, if the draft is 2.571 divided by 2, that will give me the kb of filled up, partly filled cylinder. The kb is going to be 1.285 meters. Beam transverse. What is the beam transverse? Beam transverse of the cylinder is moment of inertia of transverse section about the diameter divided by underwater volume. Now, what is the moment of inertia? Pi into d raised to 4 upon 64. And what is the underwater volume? Underwater volume is given by pi r square into the draft, that is 2.571, right? So if I cancel pi with pi, it is 8 into 8 into 8 into 8 divided by 64 multiplied by 4 square, that is 16, into 2.571. So this cancels over here, and so basically it will give me 4 divided by 2.571. That is 1.559. 1.559 is the BM transfer. So we have the kb here. kb I will write down here as 1.285, and BM transverse is equal to 1.559. We still have to find out the kg. kg we have not found. Let us find out the kg, and the basic calculation method always of finding out kg is kg by moments. Now the empty cylinder is 82.394. Yeah, so the weight of empty cylinder, so weights we'll put here, kgs we'll put here, and vertical moment. This had the kg of 1 meter, right? When we pour 50 tons, so height of oil is 1.244. 1.244 divided by 2 gives me 0.622. 0.622. If the oil is at the height of 1.244, the kg of the oil will be half of the height, that is 0.622, right? And then the total displacement is 0.394, 132.394. When we take the moment, 82.394 comes here, and 0.622 into 50 gives me 31.1. 944 113.494 gives me 0.857, 0.857. So the kg is equal to 0.857, 0.857, and km, that is kb plus bm, kb plus bm is 1.285 plus 1.559, 1.559. Km is 2.844, 2.844. That gives you GM solid as 1.987 meters. But the last part of this calculation should not be forgotten, because you have free surface of liquid, and the free surface moment has to be found out. Free surface moment is moment of inertia of the free liquid about the centroid axis. That is pi d raised to 4 upon 64. Moment of inertia of liquid would be pi d raised to 4 upon 64, right? And this multiplied by density will give you the free surface moment. So free surface moment is going to be the moment of inertia multiplied by density, that is 0.8, and free surface moment divided by displacement, and displacement is nothing but 132.394, will give you free surface correction. So let us find out the free surface correction. It is 3.14 into 8 to the power 4, into 0.8 divided by 64 into 132.394. So 64 gets cancelled over here, makes it 8 to the power 2, right? And let's do the calculation. 3.14 into 64 into 0.8 divided by 132.394. 1.214. So that is the free surface correction. So if we apply the free surface correction over here, 1.214 free surface correction, then the GM fluid that we get will be 0.773 meters.